Happy Virtual Thursday, everyone, and welcome to the 6th event in our Virtual Thursday series. I'm Amelia Martin, the founder of Data Science Connect. We're the largest data science community in the Southeastern United States. However, thanks to this new virtual space we all have found ourselves in, we have an audience joining us from all over the country and the world. Before we get started, we're going to take a moment to thank an organization who makes it possible to bring content like this to you at no cost. Our presenting sponsor, Amazon Services, also known as AWS. It's an incredible honor to partner with a name like AWS. Thank you for your continuous support in making data science accessible to the world. We'll include a few different automotive-related case studies in the call to action button at the bottom of your screen. I know Patrick would enjoy hearing some of your case studies to see which AWS solution can help your organization move faster, lower IT costs, and scale. Now we're going to hear from AWS's Patrick McHugh.
Thank you, Amelia, and thanks everyone for joining this afternoon. I'm Patrick McHugh from AWS, and we're proud to be sponsoring this virtual event series. Welcome to our 6th event. Can you believe that, Amelia? We're up to 6. How about that?
I can't believe it.
The automotive industry is undergoing immense change. Vehicles are evolving from gas to electric. As you may know, Amazon recently bought 100,000 electric delivery trucks. Vehicles are evolving from autonomous self-driving. Just yesterday, Amazon announced Scout autonomous delivery vehicles that are going to be piloted in Atlanta. Whoop, 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 whoop. So we're going to have these little blue critters crawling all over everywhere, delivering stuff, mostly to my house, constantly, 24/7. The vehicle purchase process is rapidly shifting from in-person to online. Although, interestingly enough, in the early going in our poll, it looks like we're going to continue to be buying in-person at dealerships for the foreseeable future. Even the basic decision of buying a vehicle is now optional with the emergence of ride-sharing services like Uber and Lyft, not to mention the manufacturing and supply chain processes, which are continuously optimized. So how can data science help automotive companies understand and predict these changes? Obviously, AI is fundamental to autonomous driving, and how is it going to evolve for ethical decisions like swerving to avoid a child, but the risks to passenger and driver? So how is AI and ML going to handle those types of evolving situations? So we're very interested to hear from our expert panel, and I hope their companies be smarter via analytics. Thank you to our speakers for joining us today. We can't wait to hear from you. Thank you.
Thanks, Patrick. And are you going to tell us what's to the left of you?
Oh, wait, oh, to the right of me, to the left
of you.
To the right
of you, to the left of us.
This is my newly minted data bell. Yes, it is a very heavy bell. And we ring it on my team whenever someone has a brilliant idea. So if I see some brilliant ideas in the chat, I will ring it. And you don't even need to have the microphone on to hear it. It is so loud.
Patrick comes with a new prop every week and a data hat.
That's all I got. I got props. That's all I have.
We also want to thank the University of Virginia School of Data Science for being a supporting university partner in the series. Several members of their team are joining us in the audience, so reach out to them if you'd like more information on how to join the world's first School of Data Science. A couple more announcements before we get started. Registration is live for our virtual data science conference this fall, which AWS will also be a presenting sponsor of. And it will now be 3 days, feature 4 tracks, with the first 2 days being workshop driven, or the first day being workshop driven, and the last 2 focusing on presentations and panels. The conference dates are October 7th through the 9th, and the promo code AUTO40, AUTO40, will give you 40% off all registration types. We'll include more information in our post-event blast. Today, however, we're gathered to focus on data science and advanced analytics are at the core of the current transformation of the automotive industry. Throughout today's conversation, when you have a question, Please use the Ask a Question button at the bottom right of your screen and vote for the ones you want the panel to address. Without further ado, it's time to hear from our expert panel. Kathleen Staples, Manager of Electrification and Dominion Energy, joins us from Richmond, Virginia. Dr. Marcin Ziolkowski is a data scientist at BMW, joining us from Greenville, South Carolina. Dr. Ziyadi is the lead machine learning and scientist at Lucid Motors and joins us from Los Angeles, California. Erica Kilbride is a solution principal at Slalom, and she's located in New York. Sophie Yan is a senior manager of analytics at Cox Automotive and joins us from Atlanta, Georgia. Dr. Madhur Behl is an assistant professor at the University of Virginia and also the founder of F1 over 10 autonomous racing. And Dr. Behl joins us from Charlottesville, Virginia. And Larry Rosinski is a senior manager of business development and analytics at Nissan and joins us from Franklin, Tennessee. Thank you to our esteemed panelists for joining us today. So to kick things off, can each of you tell us a little bit about your background as well as why and how you are currently using data science in the automotive industry? Kate, can we start with you?
Sure. Can you hear me, Angela?
Yes.
Thank you. Like Amelia said, I'm Kate Staples. I'm the manager of electrification at Dominion Energy. I've been at Dominion about 10 years. I've worked on energy efficiency, renewable energy, and now I'm working on electric transportation. Dominion Energy is headquartered in Richmond, Virginia, but we operate in 20 states, providing clean, safe, reliable, and affordable energy to more than 7 million customers. We're committed to a clean and sustainable energy future. We recently announced our goal of achieving net zero emissions by 2050. And a significant part of that commitment is going to be decarbonizing the transportation sector. And that's why we're engaging with experts in data science in the automotive industry. Thank you for inviting me to participate, and I'm looking forward to the conversation.
Thanks, Kate. Marcin, will you go next?
Sure, thank you. My name is Marcin Ziolkowski, and I'm part of the BMW Group IT. IT Group for BMW runs technology office networks around the globe, and one of these tech offices is located in Greenville, South Carolina, which is very close to our largest manufacturing site in Spartanburg. And what is the focus of our team is bringing innovation topics that are IT related to the company. Our group scouts new technologies, checks research that's done at the universities. We collaborate with universities, startups, and bring those topics and those technologies to the company, leaving them at the proof of concept and level with the university or startup, and then industrializing it, working closer with the teams within the BMW. So we are leveraging a lot of data-heavy topics. Of course, analytics, machine learning are one of the tools that we are using to address business questions. We are not working, our team doesn't work on the product. We don't work on the car technologies mainly, but focus internally in the company. We work at the group level, not only with manufacturing, but from financial services to sales to manufacturing. You can think about team like us, about like a problem-solving team that teams within the BMW group can reach out to solve difficult tasks. Yeah, thank you.
Max, do you want to go next?
Sure. Thanks, Amelia. Thanks for having me. I'm Max Ziyadi, and I'm machine learning and data science lead at Lucid Motors. And before that, I was a staff data scientist, Smart Drive Systems. I've been, as far as I remember, I've been in transportation industry, and I got my PhD in transportation engineering from the University of Illinois, Urbana-Champaign. And before I go to your question about how and why we use data science at Lucid Motors, and I should apologize that I have to leave early. It's still a work day for us in West Coast, so I have back-to-back meetings. So my apologies for that. Why and how we use data science at Lucid? So if you think about a car is a very highly complex system and has a lot of components, teams, and departments that they work together to basically to build a car that we drive today. And you can think about from manufacturing, supply chain, all the way to designing a car, machinery, and then within a car, especially when you look at the electric car, for example, from Lucid standpoint, we have battery system and battery technology, and you have a chassis, powertrain. All these teams they work together to build a car, and there's a lot of complexity that goes to the system. And this is where a data science team in general comes in to help with those teams to help to provide a product, which is a car which is safe and sustainable. So that being said, my major interest in this space, which is pretty, I would say, very vast, different topics and areas are involved, lies on the applied AI and machine learning in transportation and automotive safety and sustainability. So I think I'll take it from there.
So I was looking at some of your cars last night, Lucid Motors cars. I mean, it really does look like it's bridging the gap between vehicles as we know it and self-driving cars with the reclining chairs in the back. And
sure, yeah. If I speak to that a little bit here. So Lucid, what we're trying to do at Lucid is actually we're bringing that luxury experience that you are expecting from a high-end IC, internal combustion engine car that we have today to an electric world. Right now, if you look at all other competitors in electric space, one single element, like one of the elements that they're missing, is that luxury experience that you would expect from a car to have. And that's where we bring that in with Lucid design. Very unique design, a lot of good features internally, and we're going to the production this year. So a lot of good actually news coming up. 9/9, remember the date. So there will be some good announcements at 9/9 this coming September. So there's a lot of good activity and a lot of good technology that we're using. And speaking of the autonomous, of course, we're building an infrastructure that anytime in future there is an autonomous technology ready, we will be able to just take it and then deploy it. So the infrastructure, we're building a very, very strong and capable, basically, infrastructure for autonomous driving as well.
So we'll be giving away a car to the best question in the audience. Just kidding. Erica, do you want to go next?
Yep, sure. Can everyone hear me?
Yes.
Great. Erica Kilbride. I'm a solution principal at Slalom Consulting. We're a local model consulting firm, although now what is local when everything is digital? So I'm in the New York office. I'm actually right now in Houston, Texas, which is where I was born and raised. But with a consulting firm, we service a variety of clients across different industries, one of which includes a rental car company out of New Jersey, Paramus, New Jersey, who was interested in, they're collecting a lot of telemetry data from different OEMs on their rental cars as well as their purchased cars. And they were trying to decide what kind of infrastructure and architecture they should use to leverage this data in finding all kinds of insights about their fleet, about their customers, et cetera. So I was actually involved in a proof of technology with the AWS connected car solution to take this streaming telemetry data and help them analyze a bunch of different use cases from anomalous driving patterns. So they, for some reason, suspected that people might be renting a car and then using it to drive for Uber, which I don't think the markup on Uber is high enough to make that a sustainable business model, but we were there to help them out anyway. As well as some unauthorized vehicle usage kind of around the lot, as well as shuttling efficiency. So one thing that will happen with a rental car is when there's less demand in one rental car location, you need to move a fleet of cars over to another one. And they were finding some anomalous shuttling times where someone perhaps took an hour longer than they needed to be, which really affects their bottom line when a customer is there waiting for a car. So basically, we were able to leverage AWS, who is a sponsor of this particular call, their connected vehicle solution and tailor it for their specific problems. So it is perhaps not using AI on a particular car, but it's using AI within the automotive industry in terms of rental companies.
Thanks, Erica. Sophie, you next.
Sure. Can you hear me?
Yes.
Okay, great. Actually, it's very happy to hear from Erica about rental car. Cox Automotive is covering the transactions, actually providing the platform and locations, around 50 locations across US for used car to buy and sell from dealer, rental companies, or OEM. So it's very interesting to hear the story about rental cars, which is becoming a significant part of the used car transactions market. So I worked in the assurance business, which supports couple products to help dealers buy and sell with confidence in Manhattan, which is the used car transaction location. If you think about that, this is not probably have some distance from retail customers. You probably know Nissan, BMW, which is the big brand for OEM. But for us, we provide services to dealers and OEM. So we kind of work behind the scene. And dealers, they buy and sell in auction setting, which if you imagine, it's probably 1 minute a car is gone. So how we can provide product that help dealers buy with confidence is a good topic, especially in the environment where digital marketplace become more and more relevant. So I have a background in statistics. I have actually some background in financial industry for a couple of years. So I'm bringing all this technique and risk management concept into product management. So that would involve analyze the client profile, the transaction profile, and the market trends so that we can provide, understand the market and product performance and help the business to make a strategic decision. So that's where I am. I'm very happy to join.
Thanks, Sophie. Madhur?
Yeah, hey, hi everyone, and thanks for sharing your Thursday afternoon with us. I'm Madhur Behl. I'm a professor in computer science at the University of Virginia. And so my group, we do a lot of research in artificial intelligence and robotics, and in general in autonomous systems. You know, from my perspective, autonomous vehicle is just a big robot on 4 wheels, but you know that might be a bit of exaggeration. And so we use a lot of data science, obviously a lot of AI. We are trying to, recently focus a lot on the safety aspects of AI, especially looking at what are the limits of, supervised machine learning and pattern recognition and motion planning, and what are the associated safety-related consequences for such a task like a fully autonomous self-driving car. So, by virtue of working on those problems, it's very natural to deal with a lot of data, both from real vehicles, from simulation, and we have our own sort of internal data science pipeline, if you will, to handle sort of all that ingestion of this large volume of data that we get. And one other aspect, which at present might seem a bit dissociative from our discussion, is related to the aspect of safe AI and autonomous driving. I also do a lot of research in this new sort of area called autonomous racing, which is related to the safety aspects. Hopefully I'll get to that later. But for the last 5 years, I've been organizing an international 1/10 scale autonomous racing competition, and about more than 20-30 universities from all over the world come and we race, and head-to-head racing. It's all about the algorithms. It's all about the AI, and I believe racing is a very good means to provide like a litmus test or a stress test to the deep learning algorithm. So I'm excited to share the panel with my peers and colleagues from the industry, and look forward to our discussions.
Thanks, Madhur. Larry?
Hey, thanks, Amelia. Hello, everybody. I'm Larry Rosinski. I am Senior Manager of Analytics and Business Development at Nissan, specifically in our connected vehicle space. I've been around cars and data, two of my passions, my whole life, my whole career, which good for me. But I studied statistics in school. I've had sort of a classic market research career and background, some of that on the supplier side, also some of it on the OEM side at Land Rover and now at Nissan. I joined Nissan in 2006, so I've been with the company quite some time. And I've done just about every job, I think, at Nissan that touches data in some capacity. And I've even done it globally. I've had assignments with the company in Hong Kong and Japan. So that's given me another perspective on our company and how we make decisions with data. I'm not a data scientist anymore. I used to be. In fact, I'm maybe one of the dinosaurs on the call today that actually did hard coding of SaaS code. So if you're in that club, congratulations, we're a dying breed. But today, my data interests and skills are all about our connected vehicle space and how we can leverage that for cost savings at Nissan as well as revenue opportunities. We have a lot of expensive consultants who come talk to us and they tell me that the space for connected vehicle data is anywhere from $450 to $750 billion in value. And we want our share of that. And my job is making sure that we get it. And data is the fuel to make that happen. So I look forward to the discussion today and how what I do ties into what all the other participants are engaged in, and hopefully bringing some good insights to the participants.
Thanks, Larry. So now that we've done introductions, let's kick off the panel conversation. The automotive industry is made up of many subverticals, from design and manufacturing to sales and rentals. How is artificial intelligence and machine learning being leveraged across these different spaces?
So I think as the consultant who kind of has a hand across multiple different industries beyond just automotive, I can, similar to the story I was talking about with car rentals, it's being used for fleet optimization, any type of telemetry information that will help with route optimization, making sure that you're putting a car that needs service into service as soon as possible, or perhaps even predicting some point of failure on the car is really going to be helpful in lowering costs when it comes to trucking companies, rental companies, et cetera, where those fees can become pretty exorbitant. And when something is off the line, it is you're losing money, basically. That's what I'm seeing personally.
Anyone else have anything to contribute there? All right, let's go into Max. Data science, machine learning, artificial neural networks, text mining. All of these technologies take time to implement, and there are a number of different stages. What does the AI lifecycle look like for automotive?
Yeah, so that's a great question. But so I would say AI lifecycle in automotive industry in general has its own similarities and differences from other industries. Let's look at an AI lifecycle in details here. So we're talking about the first stage of the cycle includes a problem definition, where you have there's a problem, a challenge that you want to tackle. You have a product to design, and then you define it, scope it. The next step is going with the development cycle, which includes all the data collection, train, dev, test cycles, and then you do the POC, proof of concept, and then you go with prototyping, and then you have the deployment and integration and monitoring and all that. If you take this as a life cycle of an AI model, an AI system in general, I would say there are two main differences that in automotive industries are unique compared to other industries. The middle part, which is the development part, I would say is very similar to all other industries. So that's typical. We talk about NLP type of work we do. You could be a computer vision work, and there's a development POC and then R&D work that you could do, which is typical in all other industries. But there is the difference lies in the basically an input and output of that system, that life cycle, where you collect the data and then at the end you integrate your solution back to the system. So in the data collection part, there are so many different types of data that we're dealing with. And as in the beginning I mentioned, the car is a very, very complex system. And the data types, the telemetry data is one type of data. The majority of data comes from that, but we also have so many different other types of data. If you think about more complex systems, you would have camera, video, and images. Then you would have noise. You would have LiDAR, radar, ultrasonic, all these types of data that you might at some point you want to be, do some insights and do some analytics on those. And that can make it very, very complex. And that's where the concept of sensor fusion comes in, and those topics that we deal with that in that space. And then you do your modeling, you develop your system, and then when it goes to the integration and deployment back to the system. Now think about a car. It's a moving vehicle. It's a moving, basically, object. It's not like in other IoT devices that you might have in your home or in limited, space. But a car is constantly moving, and you might have connectivity problems, network, cellular network problem or Wi-Fi problem that you want to, push something back to the device and basically on the edge itself. Edge here means the car itself, or you could produce and develop a solution that goes into the cloud, and you might to maintain it in the cloud. So you might have two paths to move forward. You want to have the solution back and deployed in the car itself, or you want to have this on the cloud where you basically most of your data is. And that decision can be very critical because the amount of computational power on your car, specifically we're talking about the data science and ML and AI systems that we're talking about, could be really power consumption would be a lot that you need to think about that to prioritize your solutions that you need to deploy on the edge. Luckily, hopefully, basically these days we have with the amount of computational power and the cheap computational power that we can get, it's helped us a lot in this industry to be able to build good solutions and giving the basically progress that we had in AI space in the last decades. So if you think about it, I always think about like this. So in the past, we had all these analytical solutions, mechanical analytical solutions that you would do on a piece of paper, you start designing it, and then that can be mostly the physical system that it can be a car, it can be a building or an IoT device or anything, a physical system that has an underlying analytical solution, mathematical solution that helps to design it. But when it comes to the real life, now we start collecting data. And luckily, again, thankfully, we have cheap sensors that are very cheap to deploy. And basically we can collect any type of data from any system that we want most. And then think about the data collection and the data storage. Nowadays, it's very cheap, actually, and Amazon being one of your partners in this call. So very cheap, actually, solutions that you can store your data for a very, a couple of bucks. You can store a couple of terabytes of data, and that's amazing. And then amount of this data every day that we're collecting, for example, at Lucid, is terabytes of data every day. So this development of this systems and technologies helps us from sensor to data storage, and then we have the computational power that comes into this picture. Nowadays, again, compared to the last decade, that's much better now, much faster and cheaper. So all these systems hand to hand helps us to develop a solution, an AI solution that can be and can address some of our challenges. But again, as I said, that incoming input and the integration and deployment and monitoring that in the system, that has its own challenges yet to be answered. So.
And so I think a natural segue to that question is for Marcin, and so the majority of major car companies have been around for decades. Although the automotive industry is constantly evolving, new technologies need to fit within the existing infrastructure. So how do you leverage AI in an environment where you're working with so many legacy technologies?
Yeah, so every big company, and especially company that focuses on manufacturing, operates 24/7. So there is not a lot of time to change systems. That's why there is huge amount of legacy systems that, as long as they are running, people may be afraid of touching them, or with causing interruption to the system. That needs to be planned way ahead of time. It's costly to change them. Those things are not changed every day, and not every enterprise stays on top of on the cutting edge with respect to underlying technologies or underlying systems in the company. So of course we have a lot of legacy systems, and in the sort of the data science life cycle or AI life cycle, like Mike's described it, there are two ends of it where you need to touch these legacy systems. One, yeah, and that applies regardless of what technology you may be using, what application and field that AI or analytics will be done. That's data collection. You may want to either collect data from some equipment, from a car, from equipment on a manufacturing line, from just a database, get some information from a mainframe. From interact with PLC and get amount of information from it, and then there will be the other end where the final result of this information needs to again go to some system of record. Either this will be a robot that needs to be controlled, or that will be another database that is responsible for driving some decisions. Both of them require a lot of work, and for anybody that's watching here, if you are aspiring to become a machine learning developer, you need to think about both of these ends, because they will impact first the timeline on how quickly things can be done, and the second, how exactly needs to be done, because the interaction needs to be part of the whole solution. And equal amount of time and effort is spent on integrating on both ends. To get the data real time from any system, that's difficult. Developing machine learning model on any data, that's difficult. That has some cycles, but also integrating it back and giving that decision back to the system, especially if it's not modern system, if it's not cloud system, it's not something that is ready to have plugins, adapters of any sort that interacts with the modern protocol, has REST APIs on any end. In legacy systems, you can pretty much forget about them. There will be some other technique that you will need to interact with on both ends, and that needs to be part of the whole solution. That applies to every sort of vertical in data analytics, whether that's just analysis of data, and that may be just study some patterns, or developing machine learning application that needs to take some input, like IoT application that will analyze either machine data, machine vision data, or human data coming from some other systems. The whole life cycle has these two difficult ends.
And what does that transition look like from legacy platform to?
Transition from legacy platform to a modern platform? Well, there needs some that may have a number of difficulties in development. Yes, it needs to be modern solution on one end, flexible solution on the other. When you're thinking about it, there will be some probably an protocol that interacts with the system that is maintained by a team that doesn't want to touch it, doesn't want to introduce any vulnerability to the system, and maybe doesn't want to risk any downtime for that legacy system. As long as it's running, we would like to keep it that way. So we need to be flexible in developing this interface. Maybe this is an SAP system that's difficult to interact. Maybe it's a mainframe system that's also difficult to interact, and there needs to be this whole development of the interface. And in that way, the technical difficulty is one, but it's also sort of a business case and interesting business interaction between two different teams, between team that's maintaining a system that needs to be fully 24/7 operational with someone that wants to do some cool things on data, but is not necessarily concerned with this 24/7 operability of that system, and may want to just have an access to the system. So there are two conflicting first technologies, two conflicting, maybe not too conflicting, but not fully aligned operation models for two different groups, and they need to come together and develop solutions together. So the effort of developing the interface both at the beginning and at the end of the life cycle may be very critical to the success of any analytics, of any ML application in the company. And it's also this clash of different mindsets.
Thanks, Marcin. So now I think it's time we take our currently top-rated audience question from Cordell Jones. Cordell asks, with AI, self-driving specifically, what are some of the legal implications or roadblocks you have seen, and what has been your company's response or solution? Any takers?
Yeah, I can take a stab at this, and others can, I guess, chime in. So so you are right. First of all, I would say that the biggest sort of uncertainty in this space is what is the definition of a safe autonomous vehicle that everybody agrees on, and that the regulators can also approve and get behind. So surprisingly, the very notion or the definition of what safe autonomous vehicle is still evolving, right? It's not yet pinned down and agreed upon. I know we have different levels of autonomy, and based on what level you are trying to prototype or demonstrate, certain type of safety elements have to be present. But that seems to be one sort of a reason why there is some of these roadblocks in the first place. But other than that, I think and that's also why we require a safety driver to be present in every vehicle which is getting tested. I think only recently, I believe Waymo has only started to now test in very limited situations a completely empty vehicle. But for the most part, we need a safety driver. And so that's one issue that you have to deal with, and you can, as long as you have a safety driver, you are allowed to test and gather data and kind of evaluate the performance of your vehicle. There are other roadblocks as well. So another one could be the data gathering and the privacy aspects associated with that, right? So it's not that prevalent in the US at the moment, but in Europe, there's GDPR regulations which dictate what data are you gathering. And so if you have a robot which has cameras 360 degree and it's taking footage all the time, so what are the privacy implications of that? Can you actually have some personal identifiable information in that space? So you have to, when you propose testing these vehicles, you have to have a plan for preserving sort of confidential data. So imagine, there's some section or some museum which has a sign that you cannot take photographs when you are in this area, and then you have a self-driving car which just goes by with all these cameras, right? So you have to be careful when it sort of comes to that. And so might not be, and certain states, as you know, have been more proactive than others. So that's the other thing, that if there is a specific guidance from US DOT, then there can be hope that, there is a blanket requirement that everybody fulfills, and then you can test your vehicles on the road. But what seems to be happening, but US DOT, releases these guidelines every year. I think they are up to their version 3.0 of what autonomous driving ought to look like. But many states are individually taking, different approaches. Some are more welcoming to this kind of testing, and some are still, a little bit hesitant when it comes to driving that. So I think the summary of sort of what I want to say is, there are a lot of hurdles, even when you want to, I'm coming from academia, even when you want to try and run a shuttle on your university, people are worried about liability and insurance as well. And it's not clear if there's a fully solved solution which existed, but the industry and everybody else is still trying to figure out how to best navigate. And these are the lessons which will inform what this policy eventually looks like.
I'd add that from all of the extensive work that we've done in the space at Nissan that I completely believe and agree with that there's a technological hurdle we need to solve, of course, and a regulatory one. There's a consumer hurdle as well. And it's fascinating the work that we've done directly with customers to see how quickly they are willing to adapt to autonomous technologies at the various levels. And initially, it's a very terrifying experience for them because it goes against everything they've been taught and coached their entire lives. But the comfort curve, as I'd call it, rises very rapidly as soon as they begin to experience the cues that give them assurances of safety and some degree of control. They adapt very quickly. So I think our customers might be there and ready to go on this even before our regulators are.
Kate, anything not to put you on the spot?
Yeah, it may also appear that the regulations are only important for the products, but they also are applicable internally. And particularly the GDPR requirements and the privacy is as important for the product as for protecting the privacy of employees, of associates that are working on the line. Robots that are collecting images on the line need to have anonymizers for any preservation of these images. Visual quality inspections, in case someone appears on the image, that image needs to be anonymized, and that's easier said than done with the massive scale of those systems. And being a global company, you need to adapt to the most strict common denominator to have a solution that will scale across the company, not to redevelop it in different places. So even though, let's say, United States has a little less restrictive privacy laws than other parts of the world, we as a company need to apply the most strict rules.
Thanks, you guys. And thank you, Cordell, for such a good question. So, Sophie, data science typically leverages, or beginning with Sophie, and then we'll open up to the panel. Data science typically leverages past data to predict what will happen in the future. With innovation and business models rapidly progressing in the automotive industries, including the introduction of autonomous driving in a digital marketplace, how do you take past data that was developed before those innovations and apply that to an industry that is being shaped by new technologies?
That's a good question. And I have a very quick follow-up comment on the prior discussion. It would be very interesting to learn more from the panel if the connected vehicle data, all the images collected and how they stored, traveled through the whole life cycle of the vehicle, would they be transferred to the next buyer when they become used car? So that would be very interesting to learn. And to the questions about past, how to use past data, the challenge is always here. So if we take banking as an example, we usually know how to price, the asset given the historical pattern. But whenever there is a new asset, we need to be creative and do things to make assumptions, to do scenario testing to work for that. One key component I learned from the projects about analyzing digital marketplace is that we need to find out what changed and what will not change when we change the channel or transaction type. I will give you a very quick example. So I work in the division to help provide assurance for dealers. So usually dealers will buy young cars with more confidence to buy young cars. But when the cars get older, 5 years, 6 years, 7 years, they will start to have questions. Hey, is there any issue? Is being properly maintained? So these kind of the questions won't change regardless of channels. So, but what we need to do is that how we resolve these questions in different channels. And that's where we can start to build up the analytical questions to do some assumptions testing. So we can say, hey, does image help resolve this type of question? Of course, the whole process will involve A/B testing, piloting, utilizing machine learning methodology to learn the patterns in the past and see if they are relevant to the new channel. So yeah, that's the main story I learned, is that we learn what will not change and apply them to new environment, and with testing to see if that will work.
Mm-hmm. Thank you, Sophie. Kate, you're from Dominion Energy, which is a little different from the other panelists here, in that you're a utility provider. So why are electric companies interested in automotive analytics?
Can you hear me?
We can hear you much better.
Okay, great. Thank you. So this might not be the case for every electric utility, but Dominion's roots are in transportation. In our early days, we were responsible for operating the railways and powering the trolley car system in Virginia. And while there are not exactly that many trolleys in Virginia now, we're still really engaged with transportation. We believe, and a lot of industry experts believe, that the future of transportation is going to be electric. So it's important for us to understand the characteristics of the automotive industry so that we can make sure that we integrate that segment into our operations in the electric grid safely, reliably, and efficiently. So for example, we have a lot of pilots going on right now, but I'll just mention two that we're researching that are especially interesting maybe for this crowd. So the first one is rideshare electrification. That segment is light duty, but the drivers drive a lot of miles per day, but their driving patterns are pretty unpredictable. They might be in the same general area, but it's really dependent on their pickups and drop-offs and where those routes take them. So we have a pilot program where we're going to look at electric vehicle charging habits for rideshare drivers versus non-rideshare drivers, to look at those high vehicle miles traveled segments and see how that charging pattern impacts our grid. And on the other hand, we have another pilot program with electric school buses. They, unlike rideshare, have very predictable operations, same routes. They only operate a couple months of the year, and they drive fairly few miles per day. So that segment is a stark contrast from rideshare, but their batteries are really big. So, we need to study different segments of the automotive market to determine the types of infrastructure we'll need. And we have an internal advanced analytics team, and we're partnering with some external analytics companies to help us identify those patterns and plan our grid for the future.
Very cool. I know that connects to a lot of what Larry's doing too, maybe in terms of the connected vehicle.
Yeah, definitely.
Is that true, Larry? Or did I just put words in your mouth?
No, absolutely. It's what Kate is talking about is right in step with the kind of things that we're doing. I can elaborate.
Elaborate.
Okay. So for us, the big probably swing or revolution that's happening in data and analytics is the move away from looking at static or historic data to active, live, on-demand data. That's the power of what connectivity is giving us. And just like Kate was talking about, and Sophia was talking about, some of those cases become possible when a car is talking to you and to a network. And maybe a great example of how connected data is transforming the automotive space comes in the form of insurance, right? So today, insurance is a product that's based very much on past behavior. or your demographics, how old you are, where you live, how many miles you drive every year, what your commute to work is, and how many accidents you've had. And that's the model the insurance company's been powered on for hundreds of years. But now with car data, that's changing, right? So very simple data element, odometer reading, now can give an insurance company a very precise read on how many miles per year you're driving. With your consent, of course, but it's possible. And it doesn't take very long to get from that very simple element to some things that are more complex. They can know where you're driving. Are you in the right neighborhood? Is it a safe neighborhood? Is it an area that's prone to crashes? And a step beyond that gets very granular. How you drive, the number of left turns you make, the time of day that you're out, whether or not you have hard braking incidents. Is your seatbelt on? What's your radio volume? All of these things can factor in now to an almost on-demand risk profile that wasn't available to them before. So you start to ask the question about, well, why do I need a forecasting model for your risk in insurance if I can measure it near real time? So the whole actuarial model related to cars and insurance gets turned upside down.
Mm-hmm.
So historically, a lot of our analytic energy has been focused on backward looking, using the past predict the future. And there's still roles for that sort of analysis, of course. But what if I don't need to predict? What if I can just measure and gather real time? And that's a challenge that I think all of us need to confront as we move into these new spaces.
Yeah, leading on to that kind of real-time analytics, our client, the rental car company, was also interested in not just predicting how their operations were going to go day to day using previous information, but leveraging that real-time telemetry data to know this car is due in the next hour. What is the likelihood that it will be checked back in, given where that customer is using that telemetry data and its distance from the particular retail location that it's supposed to be checked in? Also leveraging something like Kinesis Analytics, understanding the geographic regions of different cars and determining a threshold for a late check-in, giving particular weather patterns that are happening at the moment. So rather than having a broad rule across the board that 2 hours late is considered a late check-in across the United States, if we know that there is a nor'easter happening outside of Boston, Massachusetts, and on average, everyone there is going to be over 2 hours late just because we're all locked down, can we be flexible in those kind of terms based on geographic regions, as well as understanding what is happening in real time for a larger group of people?
And this is fascinating too. I know, for instance, like cellular providers like AT&T and Verizon are collecting tons of mobility data, and that's able to be monetized, for instance, to know how busy a certain intersection is at a certain time of day for maybe selling an advertising space or selling a plot of land to a restaurant or whatever. And so it's really interesting that now cars can also be, we can leverage that vehicular data in the same way that are you guys doing anything like that, Larry, yet? Like almost selling the data or monetizing that data in a way that's completely unrelated to cars?
Well, I can't get into too many specific cases, but safe to say that, yeah, we are exploring all the opportunities where data gets leveraged in the traditional automotive space as well as without. And the kinds of things that Erica is talking about with rental car fleets are high on our agenda as well. Those companies, the Avises, the Enterprises, the Hertz, they've had their world completely changed by this COVID exercise. And they envision a world where there is no human interaction required as a rental is returned, for example. That, as Erica said, you drive onto the lot, they geofence, they know that the car is arriving, they know what the fuel level is, they know how many miles you put on it, and bam, you can get a message to your screen or to your smartphone app with your invoice and all of the details. A lot of us aren't going to like that world because now they're going to know that we didn't totally top off the tank, and they're going to charge us for that little bit of gas we thought we could get away with.
And even in reading up on a little bit of Kate's space in the electric car space, I didn't realize how much interaction there was between what you guys are referring to as like the geogrid and vehicles in general. Is that a common term in the automotive space right now?
So this is Kate, we've had quite a few conversations with different rideshare companies and taxi companies. And yeah, that was a new term to me from the utility industry, but it's really common for how they do their data. When we talk about what charging infrastructure would be needed to support rideshare electrification or rental car electrification, they talk about looking at their geofence data. And it was very interesting.
It is really interesting. So the elephant in the room is self-driving cars. And Madura is, in case you guys didn't see, we already posted the article to a few of our platforms, but Madura is one of, I think, around 30 teams that will be competing in the first ever autonomous Indy 500 race. So we're thrilled to have him on the panel to kind of speak from the self-driving vehicle perspective. So one of the key qualities of a good driver is being able to anticipate and predict what others on the road might do. How do we ensure AI-enabled autonomous vehicles can deal with situations which don't occur often in day-to-day driving and are therefore difficult to gather data on? This is a big one.
Yeah. So, firstly, let me say that almost everyone will agree that nobody can agree who's a good driver. Okay, everybody thinks they are a good driver. So, but yeah, I think this question is very, very challenging. And let me just take a minute to explain why this is such a hard problem before dabbling onto what is a possible solution. So, and now we are talking about a single autonomous vehicle, and so every vehicle which is self-driven, regardless of sort of where in the levels of automation it is, it's continuously doing three things. Okay, it has to sense the world and make sense of what is around it, what are the different objects, lanes, entire laundry list of traffic lights, signs, other vehicles. And then it has to understand the scene and then plan its local path to avoid a collision and even maybe optimize high-level objective functions like energy consumption, maybe, or vicinity to another connected peer and things like that. And then finally, when you have a safe path, you execute the steering and control commands to follow that path, and you continuously repeat this cycle of sensing, planning, and action, or it's called perception, planning, and control. So this seems to be, working for decades, and all robots are built this way. What has changed recently with respect to the big boom in AI and deep learning in particular is a lot of this sensing task, a lot of the planning tasks are becoming fully data-driven, as opposed to, maybe a decade ago when we are not at the peak of this deep learning boom. Things were hand-coded by experts, and there were a lot of these if this, then that kind of rules. The advantage of rules is you can check when your rule will fail because it's sort of very human readable. But the disadvantage of a rule is that it will only cover situations that you could describe in this if this, then that sort of a format. So a lot of the underlying code of perception and planning is being done with deep learning and deep neural networks because they have proven how good they are in pattern recognition and computer vision tasks. And they have even outperformed humans in many of these specific image recognition tasks. So that seems to be a good thing, right? We can just leverage that and put it in the brains of a car. The problem is, and which is at the heart of what your question was, machine learning is largely, relying on previously seen example data sets or annotated data sets. So in order for my car to figure out what the world looks like, I rely on instances of different vehicles, different lane markings, and things like that. And this is where the problem is, right? When you, in the wild, when you are driving and you encounter a traffic situation or any sort of a scene which you have not seen before, or it's very different from the set of inputs that you were trained on, then how can you give any assurances that your car can still make a correct decision? Because it's continuously relying on this machinery of pattern recognition and matching. And so it's a very hard question. It's a very open problem, and we are trying to make some progress in that as well. But roughly speaking, I'll tell you what the approach is, right? So So there's an entire spectrum of what you could do. And on one end of the spectrum is what I believe I see most often the approach being taken by the industry, which is let's drive a lot of miles, gather thousands and millions of miles. And so that's just a way to say that, I have seen many possible situations because I've driven millions of miles. But there's also saying that all miles are not driven equally. So if you drive the same stretch of 101 freeway in California 100,000 times, you'll get good at that. But how about driving in the middle of New York or Boston? It won't generalize that well. But that is sort of like a brute force approach where let's gather as much data as you can. And I'm not trying to undermine the relevance of real world testing. I think it's very, very useful. And there is no way you can have a car without really testing it thousands of miles. But that's not the fully covered solution, right? Nobody, including myself, can claim we've seen all possible situations, or here's a list of what you need to check your algorithm against. And so that's what makes it very hard. There's always going to be a set of unknown unknowns, or what we call a countable infinite set. And on the other end of the same problem is we need a breakthrough in deep-rooted questions in AI, in deep learning. So can we formally verify that this neural network has been designed and mathematically in such a way that if your input is within this set, then this network will never generate some garbage output, right? So it's like a guarantee or a provable prediction rather than just a generalized prediction. So there's a lot of work going on both ends. And since Amelia, you mentioned autonomous racing, so here's a crazy idea, which is what my group does. We postulate that you can be safe by learning to be agile as well. Okay, so we've all encountered drivers which don't behave rationally when we drive. They indicate they are taking an exit, but they then merge on the left lane, or they will just brake check you without no reason, or occasionally, you'll get a tire blown out. So maybe that's something the car hasn't experienced. So the autonomous car needs to learn how to navigate at the limits of its agility and control when it matters most. Right? So we're not suggesting that you weave through traffic and race all the time, but when a collision is imminent, then you need to understand your own physical limits of how to maneuver. And so what better environment than racing, which offers this high speed, close proximity situations all the time, right? So that's the reason why we race. We want to use that environment to learn expert level maneuverability and agility. And so that's why I said earlier, we are treating racing as the stress test for the AI aspect of the autonomous driving. So, the question was, how do you actually handle the fact that you cannot foresee every possible traffic situation? And so the answer might not be something that I think you will like, but my feeling based on sort of what learning is, I don't think that any single AI algorithm anytime soon will be able to solve this entire problem. We still need to rely on a very meaningful mix of maybe perception and planning can be done with AI, but you still need to rely on hand engineer expert rules as well. They do offer merits when it comes to limiting the outputs of what could go wrong. And I think that's the approach which makes the most sense in short term to handle this situation. But of course, with advances in the data analytics side, with simulation playing a big role, and with also some advances in reinforcement learning and other self-learning ideas, the future definitely is promising that, everybody would want to have a car where it would be the way humans drive us. We look at the scene and we know what to do instantly. So why can't a camera do the same thing is the big sort of question here. I think it is possible because humans are an example of such a system, but for an AI system to just look at vision and be safe in all conditions, it's still much more challenging. This is a classic 90-10 problem where the last 10% of self-driving is going to take an additional 90% effort. And so I think this question of, and the space of dealing with edge cases and corner cases of machine learning as applicable to self-driving systems is very exciting. And we still have a lot more questions than we have answers, unfortunately.
So does that mean that we do sort of a hybrid sort of start to self-driving where it's manual and automated?
I think that's what we are seeing, right? So like if you look at Tesla, for instance, they are doing it in the sense, the thing I like about what their approach is that they're actually putting a semi-autonomous vehicle in the hands of the consumer. And so I can't even imagine how much data they're getting from their fleet. And that is just continuously improving their back-end pipeline of how the car makes decisions, which is, I think, a correct approach. But if I have to play the devil's advocate to this statement itself, it's, why would you put a system in place which is not fully safe, which is what, the big debate is. So as soon as you bring a human into the loop, you gain some things that human can take over where the machine lacks, but you also open vulnerabilities, right? So it's very boring to drive a car that you're not driving, right? So you cannot rely on the human at all times to be ready to take over whenever it's necessary. So this entire human interaction and the consumer element and the trust in the system, which Larry sort of touched upon earlier, those questions become very relevant when you talk about this mixed approach. So time will tell, which is a clear winner, but I think both have their merits. Like, other companies want to get to level 5 first before they think of launching a commercial car or a fleet. And then there are, these are just technical reasons. I'm sure the panel knows best about other business related reasons which come into play as well.
And I know mentioned in the article, your quote, you had a quote that was, you had sort of modest expectations for the Indy 500 autonomous race.
Yeah, I think that's it's true. I mean, I don't anticipate, in the first year, we will sort of outperform the Indy 500 champion or something like that. So but it's a good start. I would say this particular event, which is supposed to be held in the fall of next year, and hopefully we get to actually race in person by that time. I think this is similar to sort of the DARPA challenges, which in the mid 2000s laid the foundation of the entire autonomous driving industry in some sense. If you look at the leaders in this space, many of them have their roots in those DARPA urban and grand challenges. So hopefully, in the next 10 years time, we can look back to this autonomous race and say that, well, this was a point where, in motorsport racing, it's a proving ground, right? So it's no longer just about who has the best motor or the best battery pack. It's about a battle of algorithms now, right? So can you convince the public trust or gain the public trust by showing that your algorithms don't crash at 200 miles per hour? Right? Would be quite a feat. So that's what we hope to get. I'm not sure, if that would be possible on day one, but if anything, in racing, there's a saying that if everything seems under control, then that means you're not going fast enough. So this is what drivers think when they drive, and I'm just trying to build an AI with that as the objective function, simply put, right? So we'll see how it goes.
And fortunately, in this case, there won't be drivers. That's
hey, we are autonomous drivers. Okay, so
so much of what we've talked about today in terms of cars is sort of at the core of this is that vehicles are mobile data generators. They're connected inside and out. They're connected to traffic, to weather, to location, to travel conditions, to the performance of the driver, which, as Madhur said, we all are the best drivers. Every vehicle and driver has a story. How is vehicle connectivity changing automotive's approach to analytics? Larry, you're a connected car guy.
Well, I think I answered a little bit of that when I took the mic last time. It's definitely about the transition from historic data to real time or live data. But I think another way that connected data is really changing our space is in our ability to take that real-time data and use it in predictions for things like warranty or maintenance. Warranty in particular is a huge expense area for automotive companies. Even the best built cars have their issues because they're complex machines. And in order to take proper care of our customers, we're proactive about making sure that we stay in front of those things and on top of them. Historically, we've relied on survey data or warranty information or feedback from the field to identify warranty issues. With connected vehicle data, again, we can pull those data sources forward and identify from the vehicle itself in near real time if it's experiencing an issue, if it's throwing a fault code, if there's a service my car now light on, and what the component is that may be at risk or misbehaving. By pulling those data forward and doing the analysis sooner, we're able to build fewer cars with the problem and make sure fewer customers are impacted and spend less money rectifying the problem. So it's a win-win for everybody. Our customers are happier, our products are better, and our bottom line is healthier. As one example about how connected vehicle analytics can help drive our business to new places.
I would say the same use cases that Larry's talking about with Nissan are similar to what we were seeing with rental car companies, especially if you can predict when a car is going to have an issue or a diagnostic trouble code is going to be fired. It's best to do that when it's not being used by a customer, because that really impacts the customer experience. So if we can anticipate that, another 10 miles and this car is going to have an issue, let's pull it off the line and let's do an assessment of it rather than put it in the hands of someone, just because not only is it not a satisfying customer experience, but it's not necessarily the safest experience for someone either.
So another audience question we have is from a good friend of Data Science Connect, Jared. What's best practices for dealing with the ethics surrounding the Internet of Things? How does someone manage the balance between privacy, consent, and ownership of the data?
I can jump in. So, yeah, I just briefly, our philosophy is that the customer owns the data, period. We are a steward of it, we care for it, but they ultimately are empowered to do what they would like us to do with it. And I think increasingly legislation in California, in GDPR was mentioned, in Europe, are sort of forcing everyone into that line of thinking. Now, that doesn't mean we can't use the data. We engage in very thorough consent with our customers at the time they enroll their connected vehicles to ensure that we have their permission to use their data for business cases that could benefit them or benefit the company. But we don't stop there, because like so many T's and C's that we all see, it's likely that they don't read them carefully or thoroughly, or sometimes, unfortunately, not at all. So to ensure that we're being fully transparent before we engage in any case that would require us to use their data, we go for a second level of consent with them to make sure that they're opting in. That's what we do from a best practices and an ethics standpoint to ensure that we're as compliant as possible.
It's very easy to lose trust and good image if you misbehave with the data. So the company needs to have a good policy on first what to collect from any IoT device, whether that's a car or any internal system. And very commonly you see that the companies decide to collect the bare necessity to operate the system. Even if there is a possibility to collect so much more data, it is stripped really on the edge to the bare minimum that ensures the operability of this system. This may be, for example, a camera, or some IoT device that collects positions or user information, where the anonymization can be put on top of that. Or some information is removed and only metadata about an image is sent without preserving majority of the information. So first, getting the consent and making sure that everybody understands what will be the data policy, particularly with storage, because we may consent to something right now, 25 years later, when we still made this, someone still may be storing particular sets of data are understanding of the privacy of these implications may have changed. And then on top of that, deciding really to collect only the information that's needed can guarantee that we will not run into ethically questionable situations.
So another audience member, Mike Lasanke, has an interesting follow-up question to that. Mike asks, why can't you use this data, or why do you have to be so careful about using this data? There's a lot of use going on without consent, for example, phone geolocation.
Well, I don't think that even the phone geolocation is used without consent. Somewhere there is a little print that someone just did not read. And because that's a legal requirement right now, yes. So even if the fact that someone that I didn't read what was the thousands of pages that I had to scroll to finally click accept, it doesn't mean that I didn't let the company use this data. But how the legal aspect is one thing, and the good stewardship of the data is another. And to be a responsible company, you have to behave at certain standard, not to misuse it, because the trust of the customer is more important than slight chance of using data to get some more better insight.
Yeah, I think like this, this question is a fundamental question which comes up every time there's a talk about privacy, that what is the big deal about using data which is anyways getting collected, or and so the short answer is that it might be fine for anyone to use the data as long as they are transparent on what the use is, right? So to give you an idea, IoT in general, or if again we go back to our autonomous driving cars, or even let's stick with IoT, right? So like a very simple thought experiment is, I might be digressing a little bit, so I'll keep it brief. If someone just shares what they had for dinner every night on Twitter, you would think this is harmless data and nobody would care on what I'm having every night for as a meal. But if I look at the history of what you've consumed over the past month or a year, I can take an educated guess about your sort of socioeconomic status, your health habits, or your eating habits. And it's not like saying, these are very privacy invasive. It might be to some people, but the point is that you didn't intend to share this information that could be inferred from the data point you were actually intended to share. And so that's where the tightrope and the balancing act comes in, that yes, we would use this data to improve the system, which feeds back to your experience in a long-term cycle. But if there's any sort of tangential use, then you just need to be transparent on what is it that we are inferring about an individual's behavior. So for a self-driving car, you have driver-facing cameras that assist in, if you're paying attention and things like that. But what if tomorrow those cameras are also monitoring what is your co-passenger doing, or who do you ride with most often? How do you behave when you are in the vicinity of your parents or your kids and things like that? So those are privacy invasive things that could be inferred and could be monetized as well. And so that, as I think that's a very difficult point to fully sort of, provide a solution. But this criticism, which often comes up, that, I have nothing to hide, therefore I have nothing to fear. I think people sort of misunderstand that a little bit. If you think through what you are sharing and what can be inferred on that, you would not be comfortable sharing all of it. Yeah.
That's a good point, Madhur. So we've only got a little bit of time left. Thank you for all of the questions from the audience. And if your questions weren't already answered, I'm sure we can send them this way, and we'll make sure that we can still have them addressed in some capacity by the panel, and send it out in the post-event blast to our entire community. So this is the lightning round time. In one line or a couple, what is going to be the most impactful application of automotive analytics? And I'm springing this on the panel, so we we can give them a little bit of time.
This is Kate. I'm happy to start. I would think any application that can advance or read or decode battery storage technologies is going to be a game changer. We're Dominion Energy and a lot of our customers and a lot of other utilities across the country are moving to, net zero energy goals and renewable energy. And most renewable energy is intermittent. It can't be stored. And not everything that consumes energy is using it during peak solar or peak wind. So, I think being able to use the connected car data to either manage the charging load, so on kind of a one-directional use case, or use the batteries in these vehicles as energy storage in a bi-directional use case is going to be a game changer. Sorry, that might have been too many words.
No, that was perfect. Thank you.
I can go next. So in a previous life, I was in IT at an oil and gas company here in Texas. And I saw how the autonomous vehicles in the oil sands in Canada rapidly changed the perspective of maintaining a workforce up there and the productivity. You have a vehicle that can run 24/7 or a fleet of vehicles that can run 24/7. And you no longer need a workforce that is paid quite high wages to live in an area that's kind of desolate and it's hard to get to. So I could see that expanding as autonomous vehicles become safer. And as Madura was saying, as if we can increase the scale of it, applying that across a variety of different industries that are reliant on some form of driving will be huge.
I'm going to pile on the autonomous angle as well. I think it's not my space, but the more I peel back the onion and learn about it, the computing power, the algorithms, the mapping technology, all of the data science that's required to make that come together is beyond comprehension. And I think we heard a great explanation of that from Madura earlier about how one AI algorithm by itself cannot be sufficient. I totally buy into that. I hope our brightest minds continue to plug away at this problem because there's huge payoff there.
Well, I will go to the complete different end and from a car switch to how the cars are made and what impact just the existence of automotive industry has on the society. How many people are working in OEMs and the first tier supplier, second tier suppliers. That's a whole network, and hundreds of thousands of people depend on existence of the industry. And that amount of people are working and can have working conditions changed a little bit. And this bit matters, either by data analytics that can provide them a meaningful information on how to perform better, how to get their job done better, and at the same time give company information how to improve their process. And on the other side, this machine learning methods or machine learning models that can automate piece of their work, not completely replace someone, but augment and give them a tool to relieve them from some repetitive task, will have a huge impact on the whole industry, not from the product side, but from how product is made, how the car is made, and how our associates making the cars and their suppliers are working on day-to-day basis.
I can go next. I think, yeah, I can. What might be very helpful for automotive analytics is that if we have the vehicle information super transparent and to both customers and all the stakeholders across the life cycle, it will be an extremely efficient industry where we can have solve a lot of social issues like health, safety. We have a lot of populations that that have incidents during traffic. So stuff like that would be very very different. The other part would be the economic benefit that if we have a either analytics supported autonomous self-driving or extremely transparent data for vehicle history, that would change how dealers and all the stakeholders act during this life cycle. So this is a very exciting future.
Yeah, I agree. I think it's a great time to be involved in any sort of analytics in the automotive sector, industry, whether it's in academia or a small startup or a large business corporation. Obviously, I think, I have a bias towards self-driving cars. I think the biggest impact there is in the safety and the number of lives that you can potentially save every year. When done, correctly. There's also secondary effects on, the effects on a cleaner environment, more efficient use of city spaces. But I think, yeah, it's, if you look at the self-driving as an example, it has the ability to empower a significant percentage of the population and give them access to mobility, which otherwise is not possible if they are too old or too young. Right. So I have a niece, and she's just turning 2, and I hope that by the time she's 16, she doesn't have to get a driver's license, and there's a joke as well that, self-driving cars are invented by people who hate standing in their lines at the DMV. so that's a big impact. But I want to touch upon just one little point. Often when we think of impact, it's easy to look at the immediate application, but the real impact is, in the sort of tools that have been developed on the way to accomplish that. So I think in this journey of automating things and using automotive analytics, industry and academia are developing tools that can handle large volumes of data that make it easier for me to find a specific instance of traffic from billions of images which come in every day. And so I think that has a very transformative aspect, which is not just related to the automotive space. It could be applied in law or in medicine and what have you. So, if you look back at major inventions, it's the offshoot or the domino effect of those inventions, which even have bigger impacts in the future. So I think developing tools for machine learning and data analytics is going to be another big transformation. Yeah.
Thanks, Madura. And you're right that the transferable qualities of models across industries is one of the reasons that we do these industry panel series. Is we're not just speaking to the automotive industry and just automotive audience, we're speaking to all industries, and sort of the transfer of models is, I think, at the heart of data science and where it's going to have the biggest impacts. And thank you to our entire panel. This is, in terms of impact, you guys are playing a role in a future that impacts everyone. And it scares me to think about my future children in a self-driving vehicle, but it also scares me to think about them driving a vehicle. So this is the dilemma that we're all, it's in front of all of us. And I think everyone on this panel trusts data science more than we probably trust human decisions. So we can all agree on that. Thank you so much. Thank you to AWS. Thank you to the University of Virginia School of Data Science. And we hope to see you 2 weeks from today for our marketing analytics panel. Thank you again, you guys. And the video will be available immediately after we end the broadcast at the same link that the event is at. So thank you to our esteemed panelists, and we'll have to keep in touch.